An insurance policy covers losses subject to a deductible of 10,000. Losses are normal with mean 12,000, standard deviation C. Probability that a loss is less than K is 0.9582. Given that the loss exceeds deductible, there is probability of 0.95 that it is less than K. Calculate C. So two things are given here about the probabilities. That loss is less than K is 0.9582. So let the loss be X. So then we are told that probability X is less than K is 0.9582. And the second condition is that given that loss exceeds deductible, so given that X is greater than 10,000, the probability is 0.95 that it is less than K. So probability that X is less than K, given X is greater than deductible, is 0.95. Deductible was 10,000. So the given part, they said it first in the sentence. So maybe to try to throw us off. So by now we are experts at this. Now, our usual formula, A given B is probability of A and B divided by probability of B. So probability X less than K and X greater than 10,000 can be combined into this, that X is between 10,000 and K. And this is the same as probability X less than K minus the probability X less than 10,000. And probability X less than K is given to us. That was the first thing that was given. That was 0.9582, this one. Minus probability X less than 10,000. And this can be written as 1 minus probability X less than or equal to 10,000. But you know that less than and less than or equal to are the same in continuous distributions, which this one is. This is normal. So this probability X less than 10,000 is the only unknown in the equation. Let's call it Y. So then it's 0.9582 minus Y, or 1 minus Y equals 0.95. So here you move this thing over and then do the algebra, and you get Y is equal to 0.164, and Y was probability X less than 10,000. So our next step is to find the z-score that corresponds to a cumulative probability of 0.164. Because remember, the eventual goal is to find C, and C is the standard deviation. So in order to do that, we have to use our formula that Z is equal to this one. Eventually, we will need this formula. Z is equal to X minus mean over standard deviation. And C was the standard deviation. But for this, we have to first have the z-score. So we're talking about a cumulative probability of 0.164. And from the table, we can't see the 0.164 in the probability area, because remember, the table has all the probabilities that are greater than 0.5. See, probabilities start from 0.5 because these are the ones that correspond to positive z values. So to find the z-score for 0.16, probability of 0.164, we have to look at the complement of this probability and find the z-score for the complement, and then the z-score that we are looking for will be the negative of it by the symmetry of the normal curve. So 1 minus 0.164 is 0.836, and we go about finding z-score for 0.836. Now again, if you look at the table, you don't find 0.836 exactly. You find 0.8340 and you find 0.8365. So 0.836 is somewhere in between these two. So we use interpolation. So z is equal to 0.97 corresponds to 0.834, and z is equal to 0.98 corresponds to 0.8365. So 0.97 to 0.834 and 0.98 to 0.8365. And so remember, our interpolation method is 0.836 is the probability we are looking for. So that's our first entry minus the lower probability divided by the highest minus the lowest. And that gives you 0.8. So that means that the z value is 0.8 of the way between 0.97 and 0.98, which means it's 0.978. Or in a way, you can think that this one gives, if you find this expression to one decimal place, that gives you the third decimal place in the lower z value. So 0.978 is the z value that corresponds to 0.836. But remember, we were looking for 0.164. So that's the complement. And that means you negate this z value, come to the other side of the normal curve. So z is equal to negative 0.978 is the value, corresponds to a cumulative probability of 0.164. But remember, there the corresponding x was 10,000. So this is the same as probability z is less than 10,000. And therefore, the z that we found corresponds to an x of 10,000. This z score corresponds to x equal to 10,000. Remember, the cumulative table always goes in the less than direction. So in order to correspond this x and the z that you found, you had to have the inequality going in this direction. So this was one of the reasons that, remember, at this step, we changed this greater than 10,000 into a less than probability. Here, of course, we had another reason because we wanted to solve this equation. We already had this less than 10,000. But even if it was not for this reason, eventually we had to change this one into the less than, because that's the z value that we get from the table. Cumulative means it's going less than. So to correspond the x and the z, the x should also be going less than. So the 10,000 for the x corresponds to negative 0.978 for the z. So then we use our favorite formula, z is equal to x minus mean over standard deviation. We have the z, we have the x. The mean was given to be 12,000. That was given in the first sentence of the problem. And the standard deviation was given to be c. And the question was to find c. And so from this equation, c comes out to be 2045. That was choice A.